Hello friends, my name is Chandan. I am studying in Sri Venkateswara Engineering College. Today's topic is polarization and internal field. What is polarization? Polarized waves are light waves in which the vibrations occur in the single plane, and plane polarized light consists of a wave in which the direction vibration is in the same for all waves. In, in the image above you can see the plane polarized light vibrates on only one plane. Different polarized waves. The word polarized is taken to refer to the manner in which the variation is observed in the magnitude and direction of the electric field. There are three different polarized waves, namely linear polarized wave, circularly polarized wave, and elliptically polarized wave. For a linearly polarized wave, if the variation of E is projected on a plane perpendicular to the direction of propagation, then the tip of the E vector in the projection traces a straight line. Linear polarization. In case of linear polarization, the amplitude of Ex vector and Ey vector may not be equal and they are in phase. Thus, the projection of a resultant vector E vector on the plane will be perpendicular to the direction of propagation, and this direction of propagation is straight line. It is known as linear polarization. Circular polarization. In circular polarization, the amplitude of Ex vector and Ui vector are equal in magnitude and the phase difference in 90 degree. Thus, the projection of resultant traces a circle on the plane perpendicular to the direction of propagation. Elliptical polarization. In case of elliptical polarization, the amplitude of Ex vector and Ui vector are unequal in magnitude and the phase difference of 90 degree. Thus, the propagation of projection of Ui vector point from z direction looks like elliptical. Thus, it is known as elliptical polarization. Polarization application. Polarization is used in the sunglasses to reduce the glare. Polarized filters are used in the plastic industries for performing a stress analysis tests. Polarization is used for differentiating between a transverse and longitudinal waves. Infrared spectroscopy uses a polarization. It is used in the seismology to study the earthquakes. In chemistry, the sterility of organic compounds is tested using a polarization techniques. Three-dimensional movies are produced and shown within the help of a polarization. Internal field. An internal field refers to an electrical field that exists within a material due to presence of polarized atoms or molecules. This field arises from separation of positive and negative charges within the material, which creates an imbalance of charge that can produce an electrical field such as their dielectric constant and piezoelectricity. Mechanisms of internal field. The mechanisms of internal field are complex and multifaceted. One contributing factor in the alignment of dipoles within a material, which, which can occur naturally and through external manipulation. Another mechanism involves the movement of charged particles within the material and which can create a electrical field. Applications of internal field. One practical application of internal field is ferroelectric materials. Ferroelectric materials have a spontaneous polarization that can be switched by the external electric field. This makes them useful for variety of applications such as memory storage and accuracies. Another application of internal field is in the piezoelectric materials. These materials exhibit a change in the polarization when subjected to mechanical stress, which makes them useful for sensors and transducers. Finally, conclusion. In conclusion, we have explored the concept of polarization and it is a various types including a linear, elliptical and a circular polarization. We have discussed the impact of external and internal fields of polarization as well as mechanisms application of internal field. However, it is important to keep in mind that with each new discovery comes new challenges and limitations, and it is up to us researchers and practice practitioners to navigate these obstacles with creativity. Thank you for watching my video.